Question 2, translation between representations. So we're going to do a little bit of visual. We're going to do some deriving. We're going to represent the situation a few different ways and see if it all makes sense at the end. So for part A, you're going to draw a diagram, chart, or graph. Here you might be drawing a free body diagram. Remember, for a free body diagram, the arrow starts from the dot and points away and is distinctly labeled. Make sure we use appropriate labels. Use F sub G for weight force and not G, because G is an acceleration. Maybe you're having to draw the forces where they're acting on a diagram, because it's going to be a rotation problem. If the problem says it's a rigid body means that the object is not changing shape as it moves, so it's probably a rotation problem. So draw your forces at the point where they're applied. For instance, friction is at your contact point between the two surfaces. The weight force is always going to act from the center of mass. Bar charts might be drawn here. Line graphs might be drawn here. Remember the difference between the two. Don't draw a line graph, which shows relationships, when you should be drawing a bar chart. Or don't draw a bar chart, which compares two things, when you should be looking at a relationship between variables. Remember that your energy or momentum is conserved if there's no external torque for rotation. Energy and momentum is conserved if there is no external force for translation. Part B, we've got another derivation. See how important this skill is? So again, multi-step derivation is going to be one of those points. So we want to start from a correct equation. Sometimes I'm seeing them tell you where to start. So starting from Newton's second law for rotation, derive an expression for angular velocity. You're not going to have a clue if you don't know what Newton's second law for rotation is. So go to my website, Equations to Memorize, and look at those equations and figure out what they're called. That's important. It's as important as having the equations memorized. If you're in AP Physics C and you see the phrase use integral calculus, that means use an integration in your derivation. That's going to limit your equation sheet to just the ones with an integral in it. Be sure that you're setting your bounds correctly. Part C, we're going to show what you would expect to happen. So you're going to sketch a graph or a chart or something. And for this, think about your equation that you just derived. If you have R in the denominator, and we're seeing how variable changes with respect to R, then it should be an inverse relationship. If we're seeing how the variable changes and you have R squared in the denominator, then it could be an inverse squared graph or an exponential decay graph. Keep that in mind. When velocity equals 0, that means you have no kinetic energy and no momentum. Keep that in mind, because if you're drawing a momentum bar chart for something that's at rest, you shouldn't have any momentum for that object at rest. And then finally, part D is state whether your sketch, graph, chart, whatever it is consistent with your derivation. So in your justification, we want to reference that derivation. Even if you think you probably messed up, still go with it. Remember that error, carry forward. Say whether it's consistent or not, and go with it. Yes, this is consistent because R is in the denominator, so as R gets bigger, U gets smaller, or whatever it is. Say where the variable is in your equation. Is it in the numerator or is it in the denominator? As it gets bigger or smaller, depending on what's happening, then you can make your justification like that.